Hello students, I hope the voice is clear. You can cross check. Let me check whether voice is clear or not. Here, so just a second, let me check. Let me check about the voice clarity. Divider rule. Yeah, how about the signal? It is somewhat okay. Yeah, I think you are getting voice also clearly, I hope. Current divider rule. Yes. Yes, still I'm waiting to check the voice clarity. Yeah, just a second. Yes, I guess the voice will be okay. So let us go ahead. So in this session, we discuss current divider rule. So usually, if two resistors are connected in parallel to a voltage source or EMF source, then current divides between the resistors like this, as shown in figure. You see here. You can take this as a figure 1, figure 2, at the left side figure and right side figure. If the resistors are connected in any of this form and different other forms also, so that if the current divides between the resistors, then the resistors are said to be in parallel. In such case, okay, if you are asked to find the current in any of the resistors, we have to apply this rule called current divider rule or current divider principle. So to find, why we are using current divider rule? To find current through any individual resistors in parallel combination, we apply this current divider rule. Okay, from any of these diagrams, what you can understand and how to follow. Let us see here. Let us redraw this parallel combination of resistors in this fashion, like this in this diagram. So if you connect this parallel combination of resistors to a voltage source having potential difference of V volts, this V will be dropped across the parallel combination of resistors. So as a result, if current I is drawn from the source and this current divides as I1 and I2. Now, from this circuit, we can say V is equal to I into R equivalent. V is equal to I into R equivalent. Okay, as shown here. So, but R equivalent, because R equivalent is equal to R1 R2 by R1 plus R2 for the parallel combination. If you substitute here, you will get R1 R2 by R1 plus R2 into I. You can take it as equation 1. Right. Our aim is to find I1 I2 by using this current divider. To do that, let us bring one point that in parallel combination, potential difference across each resistor will be same. Here if you see the diagram. So V will drop across R2 and the same V will drop across R1 also. So, but from Ohm's law, if current I is passing through a resistor R, then potential difference is V is equal to IR. Okay, for the entire circuit, you have to get as IR equivalent. For the individual resistor R1, potential difference across R1, you can take it as VR1, VR1, and in parallel combination, that should be equal to potential difference across R2, that is VR2, and of course that should be equal to that potential of the battery connected or cell connected, that you can take it as V. Now, as in equation 1, we have V. If let us take this as equation 2. From equations 1 and 2, if you substitute what do you call from Ohm's law, as because V is equal to IR, so V1 is equal to I1 R1 for the first resistor, and that is of course equal to V, and V2 is equal to I2 R2, and thus of course is equal to V, is also equal to V. Now, as from equation 2, You can write V across R1. V across R1 is I1 R1. This is I1 R1. V across R2 is I2 R2. And of course, that is equal to V applied from equation 1. V is R1 R2 by R1 plus R2 into I, where I is total current in circuit. Now to find individual currents I1 I2, we have to simplify this in such a way that let us take I1 R1 equal to, so let us take I1 R1 equal to R1 R2 by R1 plus R2 into I. So here R1 R1, if you cancel, you will get from this I1 is equal to R2 by R1 plus R2 into I. So this is the current through the resistor R1. So R, you can also say that in the figure, if you observe, current through the resistor R1 is equal to the resistor in the opposite resistor, the other resistance of the other resistor by the total resistance. So that is R2. When you are finding I1, you have to just take this, the other resistance of the other resistor, that is R2, by total resistance is R1 plus R2 into total current in the circuit, that gives I1. Similarly, if you equate here I2 R2 equal to V, so can also write it as also can write that I2 R2 is equal to R1 R2 by R1 plus R2 into I. This implies here R2 R2 will cancel. Now this gives rise to I2 is equal to what? R1 by total distance R1 plus R2 into I, where I is total current in the circuit. So here also again, if you observe, I2, that is current in the resistor R2, current in the resistor R2 is equal to resistance of the other resistor, that is R1 by total resistance into the total current. This is how you have to remember the expressions for currents I1 I2 by using current divider rule. Okay, this we use frequently while dealing with the circuit theory in current electricity chapter.